students. It is May 7th, and we have Investigation 11. Lucky you, there is no homework tonight. So, I need to move this over a little bit, though. All right, today we are talking about scale drawings. So a scale drawing is a picture or a diagram of a figure that has the same shape as the figure, but is a different size. So below you can see we have a scale drawing of a bedroom. Notice the legend to the right of the picture. It says that 1 inch is equal to 8 feet. Here we have our beds, we have our desk, we have our chest of drawers. All right, so since 1 inch in the picture represents 8 feet in the actual bedroom, we also know the following relationships. That half of an inch is 4 feet. Since half times 8 equals 4, because half of 8 is 4, then we have a fourth of an inch equals 2 feet, because a fourth of 8 is 2. Then we have 1/8 of an inch is 1 foot. Since 1/8 of 8 is 1. All right, so as we are looking at our scale drawing, I want to point something out before we get started, because it took me a few minutes to figure out the proportions. So, since this is on, not in your book, obviously here, these little squares are all 4 feet. They represent 4 feet, okay? So I have on this side 1, 2, 3, 4, 5. So this is 20 feet long on this side. Then I have 1, 2, 3. So this is 12 feet. All right, so this is 12 feet wide. All right, so when we are looking at our measurements of our picture, if we measure the picture, we find that it is 2.5 inches, and so it's 28 inches long and 1.5 inches wide. So that means 12/8 inches. This means that the actual bedroom is 20 feet long and 12 feet wide, just as we just talked about. So when we go to answer our questions, we need to use that information. What is the actual distance between the beds? So as I was telling you, each one of these squares represents 4. So between the beds, we have 4 feet. All right. Then we look and we say, what is the actual length and width of the closet? So here's our closet. Our closet is 2 of these squares. So its length is going to be 8 feet. All right. Its width, which is only 1 square this way, is 4 feet, correct? So this is number 2 for these, okay? This is number 1. This is number 2. All right, I'm going to do number 3 on the other side. So what is the actual area of the entire room? So I'm going to do that part first. We have a 2-part question here. We have what is the area if you subtract the area of the closet. So as you know, the room is 20 by 12. So I need to do 20 times 12. Well, you know that we all like our mental math, so I do 2 times 12 and I get 24, and then I need to put that 0, correct? So the area of my room is 20 feet squared, 240 feet squared. All right, 240 feet squared. Now I need to take out the closet. The closet is 8 feet by 4 feet. So 8 times 4 is 32, correct? So I need to subtract 30. Oh, that's terrible. I'm going to redo that. I need to subtract 32. So I subtract. I need to regroup. So 10 subtract 2 is 8. 8 subtract 3. Oh, actually, that's 3 subtract 3 is 0. And then we have 2 subtract 0, and that's 2. So without the closet, the room is 208 feet squared. All right, our next question is, what is the actual length and width of the beds? So as I look at these beds, I know that the length is 1 square, which is 4 feet, and then half of that. So the length is 6 feet. Now the width of the bed is just one of these squares, right? So I know the width is 4 feet. All right, so what is the actual length and width of the desk? So I look at my desk. Now the desk is a whole square, right? So the desk is 4 feet long, right? And the width is half of one of the squares. It's only half. So what's half of 4? 2 feet, correct? All right, let's go on to our next question. All right, in our next section, we are looking at a map. So identify an object in the picture that is about, we have to go back for this question. Identify an object in the picture that is about 5 feet long. Oh, I was measuring the wrong thing. The desk is right here, 4 feet by 2 feet. The chest is a little over the 4 feet, so we put that as 5 feet. All right, so it's about 5 feet. All right, the chest is about 5 feet, correct? The chest. All right, next. That's so messy, I'm getting rid of it. All right, our next question is Andrew is on the corner over here. That X marks Andrew. All right, he is on the corner of Wilson and 3rd Avenue. So his position we know is an X. Andrew's house is halfway between Taft and Lincoln on 5th Avenue. Okay, Lincoln, you made it into the book. All right, is represented by the little house symbol, correct? So for problems 7 through 11, we need to assume that Andrew travels along the street. All right, along the streets shown above. So as we are doing that, we're going to look at our map. We're going to look and see that we have Andrew's house, we have a library here, we have a movie theater here. So our first question is, how far is Andrew from the movie theater at the corner right there to of Wilson and 6th? So Andrew's over here and he needs to go to the movie theater over here. Now right here we see that 1 inch equals 200 yards. So these are 1 inch. All right, those are 1 inch. This is half of an inch, okay? So we need to keep that in perspective. So this would be 200 yards and this would be 100 yards, okay? So how far is Andrew from the movie theater at the corner of Wilson and 6th? So let's go. Here's Andrew, he's going 200. 200 plus 200 is 400 plus 600. Andrew is 600 yards from the movie theater, right? Now we need to figure out how far is he from the drugstore on the corner of Carter and 3rd. So the drugstore is right up here, correct? So Andrew is right here. These are in increments of 100, correct? Because they're half of the 1 inch. So I'm going to go 100, 200, 300. So Andrew is 300 yards from the drugstore. All right, the next one, we need to see how far he is from the library. Library is up here on the corner of Carter and 5th Avenue. So we need to describe the 3 shortest routes he could take to the library. So as I'm looking, he could go, I'm going to change my color. All right, he could go 200, 400, 600. Oh wait, I'm counting. Yeah, 200, 400. We go from 6, we go to 500, 600, and 700. So Andrew right here on this corner could take this route in purple, and he would go 200, 400, 500, 600, 700. All right, so he is 700 yards from the library. Now I'm going to change the color to show you another route. Andrew could go like this: 100, 200, 300. Then he needs to add 200 going this direction, so that's 500 and 700. He could take that route. Another route that Andrew could take, I'll put in a different color. Andrew could go 100 plus 200, which is 300, plus he could go over here, go another 100, that's 400, plus 200 more is 600, plus 100 is 700 yards. So those are three routes that Andrew could take. How far is Andrew from his house? All right, let's do a different color for Andrew from his house. Now Andrew is still in the corner, even though we've been traveling, making him travel all over the place. His house is right over here. So Andrew is going to go this direction. He's going to go 200, 400, 500, and he's halfway in between. So half of 100 is 50. And there is Andrew at his home. It took him 550 yards to get home. All right, so now we need to estimate. So our map right here, we are going to estimate with a straight line in inches between Andrew's starting point and the corner of Carter and Fifth Avenue. Now, if I had a if I had the book out and I was actually measuring, I would be able to see that a straight line, we would just be going straight across, right? So, straight across would be about 500 yards, we would estimate. All right, about 500 yards. Lots of color on that one today. All right, next one. Let's look and see. All right, on this one, we can see that a familiar type of scale drawing is a map. On a certain map of New York City, the scale is 2 inches equals 1 mile. So if you get out a real paper map, you can see often that there's a little scale on the bottom, and it says how many inches would be in so many miles. So be sure to check it out. I love looking at maps. This means that 2 inches on the map represents 1 mile of actual distance. So, what length on the map corresponds to the actual distance of 3 miles? So I look up here. All right, so 2 inches is 1 mile, so I think about 2 times 3. So that would be 6 inches would correspond with 3 miles, right? So what length on the map corresponds to the actual distance of a half mile? Well, if 2 inches is a mile, then what's a half mile? 1 inch, correct? All right, now for number 13. What fraction of a mile corresponds to half an inch on the map? All right, so what fraction of a mile corresponds to half of an inch on a map? So we have 2 inches in 1 mile, right? Then we would have a fourth of a mile that would correspond to half of an inch, because 2 inches equals 1 mile. Then we would have half of an inch. So half of an inch, well, 1 inch is half of a mile, and then half of that again is a fourth mile. Okay, then the next part of our question is, what fraction of a mile is represented by 1.5 inches? So we could think about this in 2 ways. Okay, a fourth of a mile. So a fourth of a mile is equivalent, excuse me, to a half of an inch. So then we could do a fourth plus a fourth, and that would get us a whole inch, which would be half mile. And then we could add another fourth to that, which would make 3/4, correct? So 3/4 mile. So when I'm thinking about this, I could be doing my 1/4 plus my 1/4 plus my 1/4, right? And that would give me, is these equal half? That would give me my 3/4 mile. Excuse me. So 1.5 inches is equivalent to 3/4 mile. So what length on the map represents an actual distance of 5 miles? So I go back up to my 2 up here, and I say 5 times 2 is 10. 10 inches is 5 miles. That's quite a few inches. All right, well, good luck on your lesson today. No homework. You are so lucky, and no power up. So have a great time. You can check in with me later if you have any questions or if you just want to chit chat. All right, we could do some other math stuff. Have a great morning.